we're going to talk a little bit about reverse osmosis operation and maintenance. Like say, we've got quite a bit of stuff to cover in this one, so we'll kind of wait and maybe take the questions at the end if we can. Okay, first thing we're going to talk about a little bit is compliance. Okay, if you are a licensed producer in the state of Wisconsin, you will need to have this. You will need to have this permit. Okay, this is what's called a low impact discharge permit. Okay. So if we're going to discharge our RO water on the ground, we will need this permit from the DNR. There is no cost for this permit. The application process.
Could you come to the front and repeat or tell us whoever and answer precision questions?
So you will need, like say, you will need this. It's all online application. There's no cost for it. So if you're going to add an RO into your licensed facility, you will also need to add this permit, okay? So we're going to kind of cover this. We had some questions regarding this yesterday. Our reverse osmosis water is not clean. It is not purified, okay? When this process came into play with the Wisconsin DNR, we helped with the pilot program of this. We pulled about 25 samples of RO water out of our machine at different times of the season. We sent that water in to have it analyzed. There was not one sample of that water that would pass a safe water test. Okay, that is loaded with bacteria. Okay, under state statute, it is listed as wastewater. Okay, so if you are going to use RO water in your facility, really the only place that you can use it is for washing non-contact food surfaces. Okay, great to wash the floor. Great to wash the driveway, but that's about all you can use it for. Okay, like say, can't pass a safe water test, and it is classified as wastewater through the state. So, like say, a little thing on compliance, kind of out of the box that we get asked quite a bit. And this is kind of our chance to preach to the choir here a little bit about electricity and voltage. Okay, a lot of times we have a sugar house, which is a panel that was added on from a garage panel and a panel from the garage that came off the house panel. So by the time we get our electricity to where we're going to use it in our little sugar house out back, our voltage is typically low. Okay, so if we are running a piece of 120 volt equipment and we are in operation with that machine operating on the lugs inside of the main electrical box, we should have at least 120 volts on that machine. Okay, same thing with 240. 240 volt machine, when it is in operation, we should show 240 plus volts on the meter inside the panel with the machine running. Our biggest problem in the maple industry that we fight with is low voltage and burning out electrical motors and contactors. Okay, so like I say, be mindful of the voltage, you know, as you add pieces of equipment to the sugar house, you know, we put in a bigger evaporator, then we put in a bigger filter press, then we need a bigger air compressor. Everything has a tendency to upscale inside that building. The last thing we usually think about is how much power we have. Okay, so let's we want to try and head off some problems before they start. So, okay. How does the machine work? So when the machine is running, basically what we do is we reject the pure, or they call it pure water. It is not pure water. We're rejecting water out of the membrane, and we're keeping our concentrated sap. So really what's going on is this is what we call a semi-permeable membrane. Okay? So during the wash cycle, basically what we're doing is we're sending everything, all the soap throughout the whole membrane. Okay? And then when we're concentrating, like say, we're splitting that water basically from that sap. So how does the machine work? When we look at how the machine works, this is a picture of one of our 8-inch posts. We have a U-cup in the bottom of that post. We have a stainless steel cap that goes on, and we have a plug that basically goes in the bottom side of that membrane to plug the bottom side of the membrane. If you have a vertical RO post, usually what happens is our permeate water is coming out the top of that post. We'll show that here in just another picture. But really what's looking at the top side of this membrane, All of our sap is getting pumped in, our concentrated sap. It's traveling through that little orange layer, which is our semi-permeable membrane, and that water is getting funneled. It spirals around. It goes to the center of our RO membrane, and that is where it's discharged. Usually, out the center, whether it's on the top, if you have a vertical membrane or a vertical cart, or if you have the horizontal cart, it's going to be coming out the end. But like I say, it's going to come out your water is going to come out the center of the membrane. The concentrated sap is going to come out one of the side ports on the post. So another way to look at this is our high feed pump, our turbine pump. We're taking our high pressure sap into our membrane and we're forcing it through there. All of our water is spiraling toward the center. Our permeate is coming out the top. Our concentrate is coming out the side. Now, we're going to stress a couple things in this seminar because, we get a lot of people that buy a lot of different sizes and types of RO machines. And the larger machines have excellent recirculation. The hobby machines have a limited amount of recirculation. Okay? Why is recirculation important? So if you picture a RO membrane like a giant screen door, and all the holes in that screen is where our water can pass through. Okay? So as the day goes on and you're filtering roughly that water out of that sap, we can plug up holes in that screen. And the more of these holes that plug up, our pressure increases and our flow rate declines. So that is why we have, like on a CDL machine, on a 600-gallon machine or larger, we have a recirculation pump that is built down into the bottom of our post. So, few differences in the machine. CDL has the patent on this design right here. CDL has the patent to run an internal pump where we can pump pressurized sap across the face of the membrane or over the screen surface to keep that surface clean so that I can keep separating that water. Okay? Machines with really good recirculation can run a 12, 14, 16, 18-hour day and really not lose much flow rate. Okay? So with that being said, some of the competitive machines, you will notice all of their pumps are external. They sit on the outside of their post. Okay? And they have to use the suction side of their pump to basically draw water through this membrane versus forcing water with pressure through the membrane. So that's really kind of some of the differences in how the RO machines work. Okay, these particular machines have a 1 horsepower pump and they recirculate about 85 gallons a minute of liquid across the face of that membrane to keep it clean. So with that being said, smaller hobby machines, limited amount of recirculation. The larger commercial machines have a lot more recirculation, and that's why they can run. And that's why they can run a longer day without losing flow rate. So we're going to discuss a little more of that kind of going forward. So pre-filters. Plugged pre-filters can limit performance, okay? Depending on the RO machine you have, this particular machine, we have a pressure gauge before and a pressure gauge after the filter. So when we see a big drop across that gauge on this particular machine, we know that pre-filter is getting plugged, okay? I'm not going to call sugar makers cheap, but they surely are thrifty. You can reuse these filters, but as we reuse filters, our flow rate is definitely going to go down, okay? So next time you start up your machine with a brand new filter in, kind of document, once you start your concentration process, document what the feed pump pressure is. Usually on most of our RO machines, we have our feed pump pressures, and then on our other gauges on our machine, we have our high pressure pump. So document that feed pump pressure when the machine is in operation, and you will start to notice when your filters are getting plugged, that feed pump pressure will start to drop. When that feed pump pressure starts to drop, we are limiting the amount of liquid that we are putting into our high pressure pump. When we limit that amount of liquid, our flow in gallons per hour is going to go down. If I can't get the liquid to the high pressure pump, I can't concentrate my sap, okay? So that's really is the key. So pre-filters can definitely limit performance. Oops. Well, maybe. Okay. We're going to talk about Brix versus flow rate, and we're going to talk about rejection rate, okay? RO machines are nothing new. They've been in our industry for quite a while. We've had one at our place for well over 30 years now. The thing you got to realize is performance and how these work, okay? So what we're going to do is, this is an example of a 600-gallon RO membrane, and we've got incoming sap at 2 Brix. We're going to concentrate to 4 Brix. So what happens is, that is a 600-gallon an hour membrane, and that is at a 55-degree temperature. All of the membranes that are used in RO machines are rated at a 55-degree temperature rating. If you are concentrating sap that is 31 degrees or 32 degrees, the flow rate will be a lot less, and we're going to go through that here kind of in the next couple slides. So with that being said, we have a 50% rejection rate. That 600-gallon per hour membrane will give us 300 gallons an hour of concentrate and 300 gallons an hour of permeate. Okay, and like I say, once again, that is if our sap temperature is at 55 degrees. Now, as we go up in concentration, our flow rates drop dramatically. So say, for example, I am up to 20 Brix. That 8-inch membrane will only flow 300 gallons per hour total, okay? Which is going to give me 24 gallons per hour, or 24 gallon a minute of concentrate, 276 gallons a minute of permeate. So you will see, the higher that we go in Brix, our membrane performance drops down, okay? So we need to kind of keep that in mind. So with that being said, our first step from 2 Brix to say 8 Brix, okay, this is what we call a 75% rejection rate. We are removing a lot of water, okay? Now, once we get to 8 Brix, 10 Brix, 12 Brix, 14, 16, 18, you will see that it drops off dramatically, okay? So the higher that we go in Brix, we're really removing just a small amount of water to get up to that next level of Brix, okay? So with that being said, like I say, we like to see, if you don't have a specialized machine, say you've got a, so we're gonna classify our machines 600 gallons an hour and over, and 600 gallons an hour and under. And really, by most manufacturer standards, they're all kind of built the same way. Once we get over a 600 gallon per hour RO, we usually have really good recirculation, good pumps. Once we drop below, say, into our 350s, 250s, and 100s, smaller pumps, limited amounts of recirculation, and we have to run a lower rejection rate, okay, because we don't have that amount of recirculation. So if we want to be safe on like a 600 gallon per hour machine, 1 pass, we can concentrate 2 to 8. That's going to be a 75% rejection, okay? That is treating that membrane respectively. It's treating it to the point where I can get it washed good on the end of that day, and I could fire up the next day and I'm not losing flow rate, okay? Now, if we look at a machine that's, say, a higher concentrating machine that goes from 2 Brix to 24 Brix, that's going to be a 92% rejection, okay? So that's going to be a little different style of machine. It's going to have booster pumps. It's going to have a lot of different equipment on it that allows it to do that, okay? So temperature and flow rate, it's hard to see. My chart ain't very big here. But so we look at a correction factor of 1. So if our sap temperature is at 55 degrees, we're going to have a correction factor of 1. That's kind of the level playing field. As our temperatures increase, if our sap temperature, say, for example, goes up to 65 degrees, our flow rate actually increases, okay? Most of the time in the maple world, we don't get much sap over 50 degrees. It is usually under, okay? So when we start going the other direction, we start looking at slowing that machine down. The colder the sap, the slower it flows through that machine. So when we get down to 32 degrees, we've got a correction factor of 0.672. So why is that important? Well, we're going to kind of discuss that here, in the next couple slides. One of the things that we're going to discuss too is we're going to discuss membranes and how clean they are, okay? Everybody is pushing their ROs harder and trying to concentrate sweeter, okay? That's just kind of the nature of the beast. As we're getting membranes into clean, we are seeing a lot of membranes come in at 55% performance or less. Once we get them impacted that far, it is hard to get them cleaned up to the point where they want to function really well in the future. Okay? So it doesn't seem like a lot of difference, but if we take a 600 gallon an hour 8-inch membrane and we get it cleaned up and it's operating at 90% of new, that seems like a pretty good rating. And from a membrane rating after it's cleaned, that is a very good rating. But what does that difference come out to? That takes that membrane that's 600 gallons per hour and immediately drops it down to 540. Okay, so just that 10% difference in performance knocks that performance of that whole machine down quite a ways. So say, for example, this is a 600 gallon per hour RO. I got a 90% membrane in there. I'm already at 540 gallons per hour. Okay, that's as good as that machine is going to do with a membrane that flows at 90%. Now, I want to throw in a temperature correction on top of that. So say, for example, 600 gallon RO, 90% membrane, I've got 36 degrees sap. Well, I've got a correction factor of 0.719. So I take that 540 times 7.19, my flow rate is down to 388 gallons per hour on a 600 gallon an hour machine. Okay, this is where cold sap, dirty membranes really make it tough to get these machines to perform. So we get a lot of calls in the spring of the year saying, hey, what's going on with this? Why won't this machine run any faster? And, the first thing we ask is, what is the temperature of your sap? Because that is the first correction factor that has to happen. So, okay, incoming Brix out of the woods versus rejection rate. With the CDL machines, 600 gallons and over, I feel pretty comfortable in advising people that, we can run 80% rejection in one pass. We've got really good recirculation. Those machines will run really good there. So 75 to 80% rejection, definitely an acceptable level. Now, with that being said, we've got to look at our Brix or our test of our incoming sap. Okay, so if I have one Brix sap coming in out of the woods, say I started early season, my sugar content is very low. I've got one Brix sap coming out of the woods. The most that I can run that, or the highest I can take that one Brix sap up to on an 80% rejection rate, like on a 600 single post machine, is 4.5 Brix. Okay, if I bring that in and I take that 1% sap and I try to go to 8, I'm going to have some issues. And this is what usually happens. This machine gets turned on. Early season sap, if they get at it really early, is usually not very sweet. Might have a little metabolism going on in there. And then at that stage of the game, I start to force that stuff through that membrane at a really high rejection rate. And I follow my membrane really for the entire season. Okay, so be mindful of that first run. And if my sugar is low, I can't concentrate that high. Now, with a hobby machine, we usually call our rejection rates at 50%. So like in the CDL world, a Nano, 100 gallon an hour, our 250, our 350 gallon per hour, those are all going to be considered our hobby machines yet. They have a limited amount of recirculation. So we really only say one pass through that machine, we should see a 50% rejection rate, or we should be taking out roughly half the water. So with that being said, we look at that hobby RO machine, one Brix sap coming in, the most I can take it to safely on a 50% rejection is to 2 Brix in a single pass. Okay, so if you got one Brix sap coming in on a hobby RO and you try to take it to 6, we're going to have some issues. So, like I say, be mindful of how sweet it is. So I've been in this world a while now, and one of the things that I look at is we get into some customers in different areas of the country. We've got some folks that make syrup just off the Canadian border up in northern Minnesota, and they start grumbling and complaining when their sap gets down to 2.5 Brix. Okay, when I start with really sweet sap, I can concentrate a lot higher. So say for example, I've got 3 Brix incoming sap on a hobby machine, and I want to stay within that 50% rejection. I can go 3 to 6, not a problem. Okay, that's still a 50% rejection because I'm starting out with more sugar. So like I say, be mindful of that early season sap that's pretty weak. So like I say, we don't concentrate it too high. Like I mentioned before, small machines versus large machines, hobby versus commercial. Really our hobby machines are nano ROs. Our hobby machines, like I say, limited amount of recirculation, small pumps. And then we get into our 600 gallon an hour machines, or 1, 2, and 3 post machines. And then we'll get into, like I say, we'll get into our, our automated and our large scale commercial machines. So like I say, we really need to make the designation of what we're buying. So one of the pieces in the sugar house that's always too small, the RO machine. It's never big enough. Why is it never big enough? Because they usually get expensive. When they get bigger, they get expensive. Okay, so that's the machine. Even on a hobby scale, we run them harder than we're supposed to. Okay, so we need to be mindful, especially if you're buying these small machines like this. If they say 600 gallons an hour per day, 900 gallons per hour a day, we need to be respectful of that. These machines here, and we see it all the time. Somebody will buy a 100 gallon an hour RO or a 200 gallon an hour RO, and they'll try and run that thing for 22 hours a day, wash it for an hour, and then start it up and run it for another 22 hours the next day. These machines really aren't built for that kind of volume. Okay, so like say, if you want a higher volume machine, you're going to have to, like say, get up into the larger machines. Okay, like I said before, recirculation is the key. That's the key to the difference between the commercial machines and the hobby machines. We got to keep that membrane clean and clear when it is operating so that we can continue to take that water out. Okay, we kind of talked about this. So let's talk about Brix levels. So maximum Brix on any of our hobby machines. So that's going to be our 350, 250, 125, basically 600 gallons and under. 50% rejection in one pass, maximum Brix of 8 Brix. Okay, we don't want to exceed 8 Brix. Okay, we have a limited amount of recirculation. As that sap gets sweeter, what are we doing? We look at that permeate water when it goes into a stainless steel tank. It's nice, clear water. We're retaining all of the garbage, all the microbial contamination, all the sugar, all the slop. That's what we're keeping. And the more that we concentrate that and the higher that sugar gets, the harder it is to force it through that membrane. Okay. So, like I say, we got to be mindful that we don't go over 8 Brix on any of our hobby machines. And like I say, that's going to be 350 in the CDL line, 350 and under. So, okay, what membranes do you have? I get a lot of calls in the spring of the year from customers all over the place. And I'm going to tell you this up front. If you bought a membrane off of Amazon, I don't know what you bought and I don't know how to clean it. Okay. And unfortunately, if you built your own RO machine, I have no idea what you built. Okay. And the customers usually get very upset with me in the spring, and it usually ends up with a few foul words and a click, and the phone call is ended because the customer's mad because I won't help them. I don't know what you have. If the membrane didn't come from us, and if you built your own machine, I don't know what you got. I can't tell you how to clean it. I can tell you how to take care of our machines and our membranes because I'm familiar with them, but I don't know how to take care of yours if you, like say, if you ordered your own membranes or if you made it yourself. So kind of puts us in a tough spot. So with that being said, if you are going to be a hobbyist and you are going to dabble on building your own stuff, people do it all the time, buy a maple membrane. I can tell you what you can do to get it clean. Okay. If you bought something off Amazon, I don't know what you bought. I don't have the specs on that membrane. I don't know how to get it clean. Okay. What pH we can wash at. All of our maple membranes, we can wash at a pH of 12. Okay. The reason that we have maple membranes versus water membranes is to get maple membranes clean, we got to take our pH up to 12 to get all the stuff washed out of them. Water membranes, if we take a water membrane up that high on pH, we're going to expand that membrane to the point where it's going to start to tear that semi-permeable membrane inside, and we're going to start to bypass sugar. Okay, So, going back 25, 30 years ago when we put in our first RO machine, we had a version of the maple membranes. Back then. They ran very slow. So we pulled our maple membranes out 30 years ago and we ran water membranes. Okay. We lost sugar. Okay. We lost probably a quarter point of sugar. Doesn't seem like a lot, but you take that times 300,000 gallons, it's a lot of gallons of syrup. Okay. The reason that we ran them is they ran fast. By today's standards, our maple membranes are really good. Okay, they're built rugged. We can wash them aggressively and we can keep them clean. So, like say, know what you got for a membrane, know what you can wash it. Okay, never go above the recommended pH. So, what happens when we add soap? Soap expands that membrane, it makes it grow in size. Okay, so when we're running that membrane on sap, we're usually neutral. 6.5 to 7.5 is the incoming pH of sap usually. That membrane kind of sits right in the center. When we're washing these membranes, we take the pH up to 12. What that does is that opens up that membrane and that allows us to wash that dirt and that organic material out of that membrane because we're opening it up and we're giving us the ability to rinse that material out of there where it was kind of compacted in there before. Okay, how much permeate do I need? Okay, really it's dictated, like if you have a hobby machine and you got a 125, minimum of 125 gallons per hour. Okay, if you're running 8-inch membranes on machines, like a 600 gallon RO, and it's got a single 8-inch post, minimum of 500 gallons of water. Okay, if I have 4 8-inch posts, minimum of 2,000 gallons of water. If I have 10 8-inch posts, minimum of 5,000 gallons of water. These are the minimum requirements for those machines. People usually err to the small side on saving water for their RO. If you have the tank space available, run more water. The more water I can rinse with prior to my wash, the more water I can wash with after my wash, the better shape my membranes are going to stay in. Okay. Usually, what happens is people kind of cheat and they don't run enough water. And when we don't run enough water, we don't really keep these machines as clean as we should. Okay, so how should I use my permeate water? Well, the first thing we want to do is when we shut down, say our machine shut off, we're done concentrating for the day. I'm going to be the first one to tell you that anytime you concentrate sap with an RO machine, it needs to be washed. Okay, if you got a small RO machine, I concentrated sap with it, well, I'll rinse it today and I'll wash it tomorrow. No. Every day we concentrate sap with an RO machine. The RO machine needs to be washed. Okay. I'll just rinse it and we'll finish running it tomorrow. That's really not a good practice. So machine shuts down. We're going to rinse the machine. Our post or our membranes are full of sugar. Okay. We want to recover that sugar. Okay. So what we're going to do is we're going to switch over to our permeate. We're going to start pumping our permeate through that machine. We want to make sure that we keep our concentrate flowing into our feed tank for our evaporator, our storage tank. We want to recover that sugar out of that post. We don't want to throw that away. Okay. Once we get that sugar out of that post, we can continue on with the rinsing process, and we want to run about half the water that we save. So say, for example, I've got a 600 gallon per hour RO. I save 600 gallons of water. I want to run 300 gallons or half of that water first as a rinse to make sure I rinsed out a lot of that sugar and a lot of that organic material out of that membrane. The next thing I'm going to do is I'm going to do a wash. Okay. Now, if I am running a hobby machine, okay, 300 gallons an hour or under, I want to start with hot water in my wash tank. Let's get some 85 or 90 degree water. Let's start washing with that hot water. Our large machines, 600 gallons and over, we have enough recirculation on those machines. They will build heat during the wash process. We don't have to worry about it. But the small machines, we got to end up with, or we got to start with hot water. Now, with that being said, some of the manufacturers of the small hobby RO machines do not have high temperature shutoffs or high temperature safety switches built into their equipment. I'm not going to go into who those manufacturers are, but there are two of them. Okay. Our machines will shut off usually between 108 and 113 degrees. Generally, they're set most of the time at 110. Sometimes we see them at 108. Sometimes we see them at 113. We don't want to put water hotter than that into our membranes because we are going to cause damage. Okay, so our machines are safety switched that if the water temperature comes too high on the feed pump, it's automatically going to shut that machine down so we don't damage the membrane. So like I say, with that being said, two manufacturers out there do not have that on there. So if I put hotter water than that in there, I'm going to wash it, and there's a good chance I'm going to cause some damage to that membrane. Okay. Once that wash cycle is completed, if you do not need to run that machine immediately, and it's later in the day or in the evening, don't be afraid to let that soap sit in that membrane overnight. Okay? What do we know about sanitizers? Sanitizers work based on contact time. Okay? The longer that material in that membrane time has that contact time to that soap, the more of that material will be ate up and degraded where I can rinse it out of there. Okay? We can have too much of a good thing. Okay? If I'm going to be shut down, say I'm going to be froze up for 3 days, I don't want to let that soap sit in there and be that aggressive for 3 days on those membranes. Okay? So what I'm going to do, if say I'm going to be froze up for a week, okay, what I'm going to do is I want to run that rinse, or I'm going to rinse some of that soap out of them membranes, get them rinsed out, and I might save some of that water. And then if I'm froze up for say 6 days, 2 days from now, I might run, on a bigger machine, I might run a couple 100 gallons of water through, freshen up them membranes. What do we know about that permeate? It's loaded with bacteria. Okay, where's that RO machine kept? When it's cold, it's usually kept in a nice toasty warm room so it don't freeze. So I'm growing all kinds of goodies inside that membrane while I'm shut down for that week. So I want to keep them membranes freshened up by putting some permeate through there and flushing them out every couple days if I can. Okay. So like I say, with that being said, like I say, that second half of that permeate water should be flushed. Okay. We want to make sure that we never put city water or any chlorinated type of water into those membranes. They will destroy your membranes. Okay. Okay, like I had mentioned before, how does pH work? As we add soap, our pH rises, that membrane actually expands. Okay, if I go too far, I open that membrane up, I start to tear that semi-permeable membrane, and I'll start to pass sugar. So how do you know if you're passing sugar? Okay, you can take a sample, you can put it on a electronic refractometer, you may not see a reading. Okay, the best way to know if you're passing sugar on your RO, take 4 gallons of water, put it in a pot, boil it down until the pan is completely dry. If the pan is sticky on the bottom, you know you're passing sugar. If you boil that pot completely dry and there's no residue or no stickiness to the bottom of the pan, we know we're not passing any sugar. In a lot of cases, that's the only way to know when you're passing possibly 1/10 or 1/10 and a half of, or a tenth and a, I shouldn't say 1/10 of a Brix or 1/10 and a half of Brix out the discharge. It's very hard to notice. Okay, so that's really the only way to know is if you're passing sugar. Okay. So with that being said, we should wash at a pH of 12. Really, there's two ways of measuring that pH. One is a pH meter electronic. The other is with test strips. ROs are pretty solid piece of equipment. We really do want to spend the money taking care of them. Test strips are $20 or $30. pH meters around $100. Buy the electronic pH meter. Okay, let's measure that pH accurately, not relying on a color of a test strip and hopefully I got it. It looks like it's close. We want to make sure it is close. Okay. Electronic pH meters need to be calibrated before they are used. Okay. Being a Maple equipment salesman, I get to see all kinds of stuff. I sold a guy a pH meter once, and I sold him the calibration packets to go along with it. And he never calibrated the pH meter before he used it, and it was about 3 points off. So instead of washing at what he thought was a pH of 12, he was washing at a pH of around 9. Okay, which isn't much better than washing with sap. Okay, so like I say, we need to make sure that we get these devices calibrated before the season starts. It doesn't hurt to do it mid-season just to make sure something hasn't changed somewhere along the line. But it's very important that we keep track of that pH and we measure it up to 12, okay? Okay, we're going to talk a little bit about soap. There are two types of RO soap that are manufactured. There is a buffered soap and there is an unbuffered soap. Okay, so what is the difference? A buffered soap, you can add soap, add soap, add soap, add soap, add soap, keep adding soap, and you'll have a hard time reaching a pH of 12. Okay? An unbuffered soap, you can add a scoop of soap into your wash tank and it may take the pH to 13. Okay? The buffered soap is out there to kind of protect the novice from not overdoing it. The unbuffered soap is a little bit more aggressive and it allows us to get up to a pH of 12 rather rapidly and maintain it. So as you're buying soap, and if you're used to a certain brand of soap and you buy another brand of soap, make sure you know what you're buying if it is a buffered or an unbuffered soap. This particular soap here is unbuffered. When we put it into the machine, we can put in a small scoop and it'll take our pH upstairs to 12 rather quickly, okay? And we can go past 12 to 13 or 14. So be mindful, as you're adding soap, okay? So as we're washing our membrane in our wash cycle, we're washing out that dirt and organic material. What happens to our pH? Our pH starts to decrease, okay? So that's why during the first 20 minutes of that wash cycle, we need to monitor that pH of that wash water. There's a lot of times on the first 20 minutes of my wash cycle, I have to continually add soap. I keep adding soap. I keep adding soap to try and maintain that pH of 12. Once I get it stabilized, it usually stays there pretty good, unless I have a lot of material that is deeply impacted in my membranes, okay? So we need to, continuously add soap, usually during that first 20 minutes, to make sure we maintain that pH of 12. So, was the machine washed correctly? If you have an electronic pH meter, and say you've got a wash tank, or if you got a hobby machine and you're using just a 5-gallon bucket of water to wash your hobby machine, on this 600-gallon-an-hour machine, say, for example, I washed the machine last night when I got done concentrating. It ran until it hit its temperature. I come back to the sugar house the next morning. I want to drain my wash tank. I want to rinse my machine, and I want to get ready to concentrate sap. Well, before you drain the wash tank or before you throw that pail of wash water out from your hobby RO, take your pH meter, put it in the wash tank, and check your pH. This is going to be your report card of how good of a job you did washing your machine. If I come to the sugar house in the morning and I put my pH meter in my wash tank and it shows 9 or 10, I should probably wash that machine again. Okay? Now, if you're washing at a pH of 12 and you did your wash correctly, you should see 11, 11 and a half, 11 and 3/4. That should be your pH of that wash tank in the morning if you got that machine cleaned properly. Okay? So that's your report card. Check that wash tank before you dump it. Okay, membrane performance. So this is going to apply really to our 600-gallon-an-hour machines and up. If you're buying a new RO machine, or if you're buying a machine or putting new membranes into a machine, we are going to go through what we call a benchmarking process where you can kind of monitor your membrane performance, okay? So after the first 20 hours of operation on a new membrane or a new set of 8-inch membranes, really those membranes kind of find their home, they find their performance value, and they're kind of stable. That first 20 hours of operation, they're going to flow really, really well. And like I say, after that 20 hours, they kind of level off and they kind of stabilize. So with that being said, we get 20 hours of operation on that machine. What we want to do is we want to rinse, we want to complete a wash cycle, and then we want to start that rinse after the wash. Now, this is going to be the only time that we ever run our high-pressure turbine pump during any type of our wash process. So what we're going to do is we're going to start our high-pressure pump running that water. we're going to set our concentrate flow on our concentrate flow meter to 3 gallons per minute. And then what we're going to do is we're going to record the permeate flow. So if you have a single post machine, we're going to just read the permeate flow on the sight glass. If we have a multiple post machine with individual flow meters, we're going to add up all of the flows off all the membranes. So we'll add up our total flow of permeate. We're going to document our temperature, and we're going to document our permeate flow. This is what we call a benchmark, so we know what those membranes are flowing when they are technically at 100%. Okay? So then what happens is we take that correction factor once again, and we want to come up with that 100% rating. So we're going to take that 5.2 gallons per minute. We're going to divide by 0.886, which is our temperature correction, which corrects our flow rate to around 6 gallons per minute, okay, on that particular membrane for this example. In our CDL RO manuals on the 600 gallon per hour and up, it explains this process. These are cut and pasted right from our manual. So what you can do is 2 weeks into season, if you feel your flow rate is dropping on your RO machine, you can come in here, you can do the benchmark test, and you can compare your membranes to where they were 2 weeks ago to see if you're reducing your flow or if your flow rate is dropping off. Okay, so this is one way that you can benchmark and keep track of your flow rates at home or in your sugar house versus having to bring something in and have it checked or have it looked at. Okay, going back to the benchmark process, don't be afraid to do this, okay? One thing I'm going to tell you, if you're going to be shut down, say you're going to be froze up for 3 days, don't be afraid to wash that RO machine once or twice more in those 3 days' time. Just don't leave the soap any longer in there than overnight. Don't be afraid to wash that machine a couple times if you're going to be shut down for a few days. It's not going to hurt it. It's just going to help keep it clean, okay? End of season. We want to get the machine cleaned up quickly, okay? Let's get the thing packed away. Let's get it put away. What do we know about our permeate on the end of season? It's usually getting kind of crummy, kind of quick. Our ambient air temperatures are getting higher. Our sap quality is getting lower. That means our permeate quality, our bacteria level, and our microbial contamination level in that permeate is definitely increasing, okay? So a lot of times on the tail end of season, I don't like using that permeate water to store my membranes. If it gets a little skunky looking, I'll run to town and I'll buy distilled water. My machine, it takes a lot of it, but at the end of the day, I put it in really good water. It's clean. It's no bacteria in it. Put my membrane storage solution in there, put it away. I know they're stored in good liquid. So just some things to kind of think about. But like I say, store them based upon the manufacturer's recommendation. Some of our smaller machines, our hobby machines, are going to be stored a little bit differently. Some of our hobby machines get stored with citric acid, some with preservative. So it really depends on the model of RO or the manufacturer. So